Game Theory Class 10 Video 2. In this video we're going to introduce the notion of the probability of an event occurring. So before we do so, let's talk about what it means for an event to occur. Okay, definition. We say that an event occurs when the outcome of the experiment lies in the event. So for example, if I'm considering rolling a six-sided die, okay, then recall that the sample space is 1, 2, 3, 4, 5, 6, and an event could be something like rolling a 1. So we say that the event 1 occurs if you roll a 1. So that's kind of trivial. How about another example? So the event even occurs if you roll a 2 or 4 or 6. So or is important, right? Like, it doesn't matter which one you roll as long as you roll an even number. So this is what I mean when I say when an event occurs. So now let's move on to probability. And I'll phrase this as a theorem. So for each event E, I'm going to call my event E of the sample space, there's an associated number, P of E, called the probability of the event E. Okay? So P of E is a number associated to E. So if you give me event E, I can plug it into P and I get a number in return. And moreover, we have that P of E is always between 0 and 1. P of E is always between 0 and 1. And there's more I can say about this. So I can say that the closer P of E is to 1, the more likely it is to occur. Okay, so the more probable it is to occur, the closer it is to 1. And symmetrically, the closer P of E is to 0, the less likely it is to occur. So this is probability of an event E. Okay, and I imagine you all have an intuitive notion of probability, but you might not have seen it defined so formally as this before. But this is just how I think, so this is how you're going to have to try and think for the remaining of this class. So let's try and do an example. Okay, so let's start with a really easy example. You flip a fair coin. Now I have to use the word fair, right? Because I'm talking about probabilities. So I have to specify that the coin is fair. Remember that the sample space is just going to be heads and tails. And because the coin is fair, I know that the probability of heads is equal to 1/2, and the probability of tails is equal to 1/2. Like that. Okay? I know this because the coin is fair. If I had a bias coin, a trick coin, then the probability of a heads and a tails could be different. But for a fair coin, it's a 50-50 chance, so they're equally likely to happen. Let's do another example. Okay, so I'm going to roll a fair six-sided die. And the sample space is 1, 2, 3, 4, 5, 6. The probability that I roll a 1, okay, well, it's fair. That means that there's equal chance of me rolling any of the numbers, and there are 6 numbers, so the probability of me rolling a 1 is 1 in 6. The probability of me rolling a 2 is 1 in 6. And they're all equal to 1 in 6. Okay? because it's a fair die. So that's easy. What about a slightly harder one? So what's the probability of me rolling an odd number? Well, this is the same as the probability of me rolling a 1, a 3, or a 5. Okay? And everything's fair, so the chance of me rolling a 1, a 3, and a 5, they're all perfectly equal, and there are 3 possible odd numbers, so that's 3 divided by the 6 possible outcomes. Or another way of saying this is 1/2. Okay. Another one I could do is probability of something greater than 3. Well, another way of writing this is 4, 5, 6. And again, there's 3 things here, so that's 3 divided by 6 possible things, which is 1/2. Okay, I'm not going to go into too much detail on probability and do any sort of difficult examples. I just want you to get a feel of what probability means. Okay, so let's do one more quick example. This is going to be a classic probability type example. So I have a bag containing balls. In this bag I have 1 red ball, 2 blue balls, and 3 green balls. Okay. And I'm going to choose 1 ball at random. Okay. So that means the sample space is going to be red, blue, or green, the color of the ball. I'm only choosing 1 ball, so the sample space is red, blue, or green. The probability of getting a red is simply, so I didn't say it, but it's assumed, all these balls, they have the exact same shape and texture. You can't tell what color is what, but without looking at it directly. You can't tell just by feel. Okay? So the probability of getting a red ball is 1 divided by the total number of balls, which is 6. The probability of getting a blue ball is 2 divided by 6, which is 1/3. And the probability of getting a green ball is 3 divided by 6, which is 1/2. Okay? Easy as that. Okay? That's probability of an event occurring. That's the end of this video.